Alright, so this video is about finding the determinants of a matrix. So, determinants, first of all, it deals with the practical application of determinants. It deals with area of triangles and whether or not matrices have inverses. So that's why we actually learned it in the first place. But in order for a matrix to have a determinant, it must be a square matrix. Underline the word square matrix. So you think about square matrix, that's the same number of rows and columns. So like 1, 2, 3, 4. It's a square matrix. 1, 1, 2, 3, 3, 3, 5, 0, 1. It's a square matrix. It's got the same number of rows and columns. It's 3 by 3. It's 2 by 2. All those have determinants, and we could find them. If it's not a square matrix, for example, 1, 2 isn't a square matrix. It is a 2 by 1. So because of that, no determinant. Doesn't have one. All right, really important to know. Once you understand that, let's go further. All right, so the determinant formula for a 2 by 2 matrix. Suppose we've got this 2 by 2 matrix. It's got these variables here, A, B, C, and D. Where we find that determinant is, you multiply the diagonals. A times D, well, determinant. It's going to be A times D, subtract the other diagonal, C times B. So whatever that answer is will be the determinant. Also, when we write determinant, we generally show it like this. Instead of making a matrices symbol, a lot of times you see these straight lines here. They look like absolute value symbols, but basically that means determinant. So when you got the bracket, it's referring to a matrix. Make that different color. Bracket like these. The little things come to the inside there means the matrix. If it's straight lines, that means determinant. So if you ever see it without that, that's just telling you what is the determinant of that matrix. Let's actually find the determinant of one. All right, suppose we're considering these matrices. Look at this example here. It says find the determinant of each matrix. This is a 2 by 2 matrix, so it has a determinant. So we can get the product of this diagonal, 1 times 5, subtract the other diagonal, 0 times 2. So if that's true, it's going to be 5, subtract 0, which is 5. So the determinant of this matrix is positive 5. Look at the second matrix to the right here. Technically, I should draw the determinant. Instead of saying matrix equals, I should say determinant equals. So I should write it as determinant. So it's 3, 7, 5, and 2. So instead of having matrix symbols, have determinant symbols. And then multiply the diagonals. So this is going to be 6. Subtract. This diagonal multiplies. 5 times 7 is 35. So 6 subtract 35. My math is right. It's negative 29. So determinant of that matrix. I usually write DET above it. That way I know I found the determinant. We can find lots of different things about matrices. If I saw DET, I know I was referring to determinant, and that's what I just found. So that's how you find the determinant of a 2 by 2 matrix. You simply multiply the diagonals, then subtract the first product from the second product. And the first product deals with the number in the first corner to the number at the bottom there. All right, anyway, that's how you find the determinant of 2 by 2s. 3 by 3s is just as easy, even though it's a little bit more to it, so let's talk about it. All right, so this section is about finding determinants of 3 by 3s. There's a rule for it, and the rule is called Cramers Rule. Some guy named Cramer found it. Cramers Rule. Instead of writing all these variables on the board, I think I'm just going to go straight ahead explaining how to use Cramer's Rule. Cramer's Rule says this. If you have a 3 by 3 matrix, and it only works for 3 by 3s, basically what you can do is you can take the first 2 columns, put them outside the matrix. 1, 2, 0, 5, 4, and 2. take the first two columns, put them outside the matrix. Then after you do that, you can multiply the diagonals starting here. So going straight down the diagonal, 1 times 4 times 1. Well, that's 4. You can multiply the next diagonal. Let's see here. 5, 5, and 0. Keep in mind that was a 0 there. So 5 times 5 times 0 is 0. You're going to add those numbers together unless you get negative signs there. So 5 times 5 times 0 is 0, so it's plus 0. And then the last column is 3 times 2 times 2. So 3 times 2 is 6, times 2 more is 12, so it's plus 12. I call this part my bottom. Why? It's on the bottom. All right, and then you're going to go upwards. So then I'm going to multiply these diagonals, starting here, going up in a diagonal fashion. So 0 is nice because it makes the whole row 0. But 0 times 4 times 3, that's 0. Then taking the next one. This is diagonal for it. So 2 times 5 times 1, that's 10 times 1, so that's plus 10. And then taking the last one. So it's 1 times 2 times 5, so 1, that's plus 10 again. So this is my top. So I get the sum of the top. The top is equal to 20. I get the sum of the bottom. Bottom is equal to 16. And the formula for the determinant basically goes top subtract bottom. This is what determinant equals. So it's 20 subtract positive 16. So that is equal to 4. So my determinant for this matrix is the number 4. And that's how you find the determinant of a 3 by 3 matrix. 4 by 4s, we don't even bother doing by hand. It's a crazy formula. So we only do those with calculators. Anything bigger than 3 by 3, we use a calculator to find determinant because it's not fun anymore. It becomes very strange. But 2 by 2s and 3 by 3s we do. So this is how you find determinant of a 3 by 3. I will pause the video right now and get any of that as a note that you don't feel like you didn't already know. I'm going to give you another one in just a minute. You're going to find determinant of it. So go ahead and pause the video and get that as a note. So we got that as a note. Take a minute, write down this new matrix. New direction says find determinant of it. And someplace on your page, find determinant of this 3 by 3 matrix. So pause the video, try it. If you don't know how to do it, just follow me along. I'm going to explain it all over again. But if you don't need to listen to me say it all over again, pause the video, you try it on your own. And then when I get done, see if your answers matches mine. So step 1, we should have put the first 2 rows, the first 2 columns out here as 2 columns. Step 2, multiply the diagonals. This is the first diagonal. This is 6 times 5 times negative 2. So that's 30 times negative 2. So that's negative 60. The next diagonal is 1 times 2 times 1. Well, that's 2. The last diagonal is 2 times 4 times 1. That's positive 8. And this is the bottom. And then go in the other direction. 1 times 5 times 2. First number should be 10. 1 times 2 times 6. Second number should have been 12. Negative 2 times 4 times 1. That should be subtract 8. This is top. So this is 10, 22, subtract 8, it's 14. The bottom should be, this is negative 60 plus 10, so it's negative 50. Determinant is top, subtract bottom. So it should be 14 subtract a negative 50. So it makes it 14 plus 50, which is 64. So determinant of this matrix is 64. And that's how you find a determinant of a 3 by 3. All right, let's talk about how we can use determinants for more important stuff. All right, there are certain problems you get that involve area of a triangle inside a coordinate plane. And we can find the area of this triangle. We got so many different ways of finding area of triangles. If we know angles there, we can use log sines or cosines. If we know one of the legs or the height of it, we use area of triangle formula. If we know what the sides of them are, we have a formula where we can find the sides, use the sides to find the area of it. But inside of a coordinate plane, you can save some work if you know the fact that the area of triangle formula is basically, if you got all your coordinates, you put the coordinates as a matrix. So there's a 3 by 3, you make one column of ones there on the end. And there's going to be 1/2 that, positive and negative. And the positive negative sign basically is there so that you always get a positive answer. Like if this determinant is a negative, you can multiply by a negative 1/2 to make it positive. If the determinant is positive, you can multiply by positive 1/2 to make it positive again. So you just want the area to be positive because it's just weird to say area is negative. That's the reason we have positive negative sign. It's just saying make sure that you use whatever one you need to make your area positive. I would just say this. Take the absolute value of your answer here. Forget this positive negative sign. And whatever your answer is, always call it the absolute value. So if you get a negative 15 for your area, just call it positive 15. And you'll always be right. So this is the formula for area of triangle. I won't bother writing it down. So if you would right now, pause the video and write down this formula for area of triangle inside a coordinate plane. And we're going to talk about how we actually do this. And remember this symbol here, right? This symbol means determinant. So that means determinant of those numbers. So it's 1/2 times that determinant. All right, so let's go on. All right, so this is the triangle. And the directions say find the area of the triangle in the picture below. So we see the coordinates. So this is x1, y1. This is x2, y2. x3, y3. Or you can call it in order you want, but I just chose that to be the order of them. So basically my matrix would be 1/2 times the coordinate 1, 2, and then 4, 0, and then 6, 2. Then we'll put a column of ones, 1, 1, 1. All right, so I got that part out of the way. And then I need my column of my first column. I need my second column. And then you're going to get the diagonals here. So this is the first. Well, you know what? Pause the video and see if you can figure out this without me. You don't need my help to do this. You can figure this out on your own. So see if you actually answer on your own. If you are not sure, continue following with me. But if you think you can do it, go ahead, pause it, and go ahead with me. Everyone else, here we are. This is my first diagonal. This is my second diagonal. This is my third diagonal. So this is 0 plus 12 plus 8. This is 20. And then my other diagonal is here, and here, and here. So 6 plus 0, 6 times 0 plus 1 is 0, plus 2 times 1 times 1 is 2, plus 1 times 2 times 2, I'm sorry, 1 times 4 times 2 is 8. So this is 10. So top, subtract, bottom. So it's going to be 10, subtract 20, negative 10. So there's going to be 1/2 the determinant, or positive, negative 1/2. And that's going to be positive or negative 1/2 times negative 10. So I already know I need to use a negative one. And like I said, I'm not going to think about that positive negative sign anyway. I'm going to think about 1/2 times negative 10. Well, what is that? It's negative 5. Now to get the answer, I took the absolute value of that because area needs to be positive. Get the area to be 5. So the area of this triangle, area of the triangle is 5 square units. That's it. That's all I've said about determinants. So if you think you have that, I'll get that as a note. But that's all I have. Good luck.